Alrighty, I'm going to tell you about classifying angles. First of all, you need to know what an angle is. It is two rays joined by one common endpoint. So it would look something like, if I can pull it up here, there we go. This right here, this is an angle. So you can see this would be one ray, ray BA, and then ray BC would be another angle. And we call this three different names. You can call it angle ABC, angle CBA, or just plain angle B. You notice that in these two, angle B has to be in the middle. That's the important thing. So your angle, which is this right here, the endpoint that joins these two, that has to be in the middle. The next word we have to know about is a vertex. That's a common endpoint where the rays meet to form an angle. And a vertex would be where point B is in this particular instance. That's where the two rays are joined to make the angle. The next word is right angle. That's an angle that measures exactly 90 degrees. It has to be exactly 90. So a right angle, it will look like an L, but as you'll see here, the L is only a temporary thing. We can rotate this, so now it doesn't look like an L at all, but this is still considered a right angle all the way around. So even though the most common place you'll see it is like this L right here. That's the everyday way of seeing it, but in math you'll see it all sorts of ways. So just be aware of that. The next thing we have is an acute angle. This is an angle that measures less than 90 degrees, and that's why we call it cute. It's a small thing. When you think of cute babies or cute puppies, they're very small, right? So an acute angle will look like our friend right here. Now you can imagine if it was a 90-degree angle, it would look like this. We want it to be an L, right? So that would be a 90-degree angle, and you can see clearly that it's less than that. And it doesn't really matter the size of these rays. Just want to point that out. If we wanted to shrink this one here, it doesn't matter. We could shrink that. We could make this one bigger. It would still be an acute angle. It's still less than 90. I would have to rotate where this ray is for it to be, closer to 90 or closer to even over 90, which is what we're going to get to next. So the next type of angle is an obtuse angle. That's an angle that measures more than 90 degrees, and I should add a part here, in less than 180 degrees. That's important to know because a lot of people do leave that off. It's kind of a wolf. It's going to be less than 180 degrees. So we can see an obtuse angle here. And again, we could shrink this if we wanted to. It would still be an obtuse angle. The important thing to recognize is that if we look at this from a standpoint of where would it be with a right angle, well, a right angle is right here. So this is like going to be a little bit wider than a right angle. So you can see it's going to be more than 90 degrees. Finally, the last one. So we've done right, we've done acute, we've done obtuse. Last one's a straight angle, and that measures exactly 180. And you can see here, it's just a straight line. So if we had 3 points right here, right here, right here, and we call those points A, B, we'll stay away from C for now. Let's call this ABE. This would be called angle AB or angle EBA or just plain angle B. But if I was to make a ray right here, I should have drawn that straight, but anyway, and let's say we call the point here point F, we could no longer refer to angle AB or angle EBA as angle B because there's now two angle B's. There's angle FBA, or actually three angle B's. Angle FBA, angle FBE, and of course the one we started with, angle ABE. So when in doubt, use three letters to name